again, thank you for listening. I've very much enjoyed the presentation so far, and this one here I think builds a little bit on some of what was talked about in the keynote, and maybe adds in a few additional thoughts. Um, I think what we're primarily looking at is taking a look at understanding a few of the design stages and features of modern AI systems that are powered by LLMs and the related technologies therein. And w- that's why the title slide here says training, fine tuning, human reinforcement, and RAG, which will be primary facets of what we look at. I am Bremen Vance at Mercer University, and I'm happy to be presenting here with Geoffrey Sauer at Texas Tech. We'll hear a bit more about the nerdy tech side. I think is what we heard from the keynote, as well as Guisseppe Getto, who's at Mercer here with me. I'm going to set the stage for what we're all going to talk about kind of together. Um, and I'm focusing in on AI literacy as a term. I've used it frequently and read it a whole bunch over the last couple of years. And I think this phrase AI literacy obviously is useful in many ways, but I think it comes with a few substantial problems. And I'm hoping to kind of talk through some of that with you today. I'm hoping that my short discussion of AI literacy will prime us to think a little bit about why we should spend our time looking at and making sense of the technical details of how AI applications are designed and how they function. And this, I think, kind of captures the overarching, perhaps, takeaway of what our talk is going to get at. How AI systems are designed significantly impacts the accuracy and usefulness of the generated content, and the off-the-shelf or proprietary systems that most of us are more familiar with, and that our students are primarily familiar with when it comes to AI. They do have many layers of technical design that are invisible, as we've heard in some of the previous talks. And I think understanding those design points and features really are important for our work of figuring out how these systems fit into the work we want to do, as well as um, empowering users, which I think is what a lot of us are focused on as educators, empowering our students to move forward and make intelligent decisions about the work they want to. So here's kind of a summary of at a high level of what I think we're arguing, and my collaborators can kind of correct or add as they see fit. But I think what we're suggesting is that each of us, as educators in this space, should know and support the teaching of some of the technical side of AI systems. And I think we're trying to figure out exactly which aspects of the technical side we should be paying attention to. But I think that doing so is essential to our collective project of promoting modern literacy, creating opportunities for participation in the work that's being done, whether that's work for business or work in our social space or in our personal lives. I think that engaging in design, evaluation, and considering the results that we're getting out of AI, making sense of the content that's being put in front of us, really should come out of a grounded understanding of how these systems work. And again, I think a grounded technical understanding of some of these tools will set students up for success in the long run. Um, Over the last several years, the term AI literacy has been growing rapidly. If you look at Google Scholar and do a search for a hard search with quotations for the phrase AI literacy, these are the number of results that you'll get back from Google Scholar for each individual year. A decade ago, Google Scholar for 2014 lists 18 articles that it matches for the phrase directly, and you can see that we have kind of an exponential takeoff. And you can practically see when you graph it out here, the moment ChatGPT was released, there goes the curve. I think that's pretty interesting. But this phrase AI literacy is in rapid circulation, and we're all grappling with what it means. And I think that is both a good description of the project we're engaged in, but it's also something we should unpack a little bit. This isn't the first technology in writing and technical communication that has dramatically changed the way we think about what we do. I really get hung up on this quote from Andrea Lunsford in 2006 during a keynote presentation, where she directly offered us a new definition of writing, and she described it here. I'm going to just briefly run through the quote. She said that writing itself is a technology for creating conceptual frameworks, creating, sustaining, and performing lines of thought, drawing from and expanding on existing conventions and genres, utilizing signs and symbols, incorporating materials from multiple sources, and taking advantages of the resources of a full range of media. And this is very much a very much a product of the multimodal turn in grappling with the rise of personal computing and how that challenged what it meant to teach writing. It opens up the idea that writing actually covers a much wider range of human work, and that means it requires us to grapple with the skills involved, and that means the knowledge and skills that we have to have as educators. My question, as we think about what AI literacy is what are the limits of our understanding of traditional literacy or even digital literacy or any other kind of literacy that we have? What are the limits of our understanding of those things when we try and apply them to AI technologies? I think there's some significant barriers to just porting over what we know, and that means that we got to do some work. In 2015, De Palma and Alexander they did a study in which one of their students they quoted said that working with their multimodal project was like a bag full of snakes, and that became the title of their article. They found that students who are attempting multimodal projects that integrate a wide range of media, not just text, in their writing classrooms, often struggled because they were applying what they called print-based strategies. They were applying traditional logics of rhetoric and writing. And so students wound up defaulting to very vague descriptions about what they were trying to do. They underestimated the complexity of the tasks that they were trying to take on, especially the technological and functional side, the new ways to think about what they could do. And so that struggle of taking what we know about writing and turning that to a multimodal project, or taking what we know about any other kind of literacy and applying it to AI, I think is on my mind quite a bit. This reminds me again of another interesting moment in our scholarship, where Jenna Eldred, this is the title of her book review. She reviewed 3 books that came out around the same time. And the title was "To Code or Not to Code. If I can't program a computer, why am I teaching writing?" And this really stuck with me. If I can't program a computer, why am I teaching writing? We have a very clear division, in the way we educate our youth, that separates our focus on language with our focus on technology. There becomes a track. It's an unstated social track, but this idea of coding or writing is kind of built into the way a lot of us think about what we do, and I find that quite troubling. Eldred suggests that teachers of digital communication, all the way back in 2006, needed to consider this, or needed to kind of reflect on if they should profess less and learn more. That was the phrase that kind of stood out to me. Maybe we should profess less and learn more, and that has to do with just making sure we actually have a good grasp of the fundamentals that underlie the projects that we're assigning. I think that's worth holding on to as well as we think about AI literacy. So if we ground literacy as a term in reading and writing practices, I think carrying those assumptions about print-centric traditions, habits, expectations, what makes for effective communication. If our goal is to transfer and impose what we know on another domain, we're going to miss things that I think are pretty important. This idea really hit me when I went back to Walter Ong's work, where he kind of discussed the difference between a print-centric culture and an oral culture when it comes to their relationship to language. He said that people in a print-centric culture, which was everybody, have a very hard time understanding the conventions and relationships to oral language that communities had before print became so dominant. We had a hard time just conceptualizing why certain conventions in our oldest texts were there, which are often associated with orality instead of the habits we would do with writing. And I think that maybe as we try and conceive the habits and relationships we have with information, and when we work with AI, applying centric logic may make us less imaginative than we maybe need to be. So I think advocating for an understanding of technology is a key challenge. Again, I'm going to go back to the scholarship and point to Cynthia Self all the way in 1999, who argued that technologies may be the most profound when they disappear, meaning that they're fully integrated and having a big impact on our lives. That's exactly when this happens is when they develop the potential for being dangerous, because they exert that power without our ability to intervene and decide for ourselves whether or not that is the way we want to go. So kind of keeping things visible, as I heard in the previous presentation, I think it was Nupur, talking about making AI visible and kind of paying attention to how things work is a pretty big deal. In my slides, I have a number of AI literacy models that I've pulled from a few different places to kind of think about what it means to be competent with AI. Here is a 6-part model that focuses on knowledge, evaluation, collaboration, contextualization, autonomy, and ethics. And we've heard certainly about some of these topics in the presentations today, and many of the presentations about AI over the last many months and years. But I think that first one, knowledge, is kind of where we're kind of leaning into a little bit in our talk today. This lines up with a 16-part, and I'm not going to really go through this in detail, a 16-part model from some computer scientists. They did a scope study where they went and they consolidated AI research to figure out what people need to know to be competent using AI. They came up with this extensive list. And when I share out the materials, you can see that this list really focuses in on a lot of knowledge building and a lot of application. Can we understand what the technology is, what it's meant to do, how it works, and how it could work if we applied it in new situations? And then I'm going to come back to this idea. This is what they kind of get at on it. AI literacy is a set of competencies that enables individuals to critically evaluate AI technologies, back to critical, to communicate and collaborate effectively with AI and use AI as a tool online, at home, and in the workplace. And in order to achieve that, they really think that we need to build up those foundational applied knowledges. And then one more plug, since I think Stuart Selber may be in the room. He's certainly been in some of the rooms. This model actually draws on his multiliteracies book, and the focus on functional here is kind of where we come back in. Becker et al. In just last year put forward their framework. They said that for the functional side, we need to make sure we understand the core mechanisms of how AI works, identify the capabilities and limitations of various AI technologies, become familiar with standard AI interfaces and platforms, and interact with AI-driven tools and applications through effective prompting. And again, to really get a sense of what it's capable of and what we should worry about and not worry about, really got to dig in and kind of ask questions about how it's processing information and getting to the results that we're seeing. Turn it over to Jeff.
Hi, everybody. I'm happy to be here. I'm a little embarrassed. I'd proposed this paper as a sort of a technical overview of Gen AIs, and then only after that was accepted was I invited to come do the keynote address, which I made a more lengthy version of this. So there's going to be a little bit of repetition here. If it's okay with you, we'll go through this a little rapidly and talk about a few things I didn't mention in my earlier talk this morning. Bremen, if you can move to the next slide. One of the things I think is important about the LLM databases is the extent to which it's important to understand what databases are and how they work. Peter McWilliams, a best-selling computer author in 1981, had a book that he published, I think it came out in 82, called The Personal Computing Book. He said in that book that there are 4 kinds of computer programs in the world. There are word processors, and there are spreadsheets, and there are communication programs, and there are databases. And he said when he talked to people, they all nodded at all of those. And then when he asked them to explain to him what databases actually were, everybody, almost everyone he spoke to, shrugged. They said, we've heard the word, we don't really understand what they are or how they work. I find that still to a large degree in 2025, it's often the case that databases are a bit of a mystery. There's something everybody nods at because you've all heard of them many times before and you know they're very important to the world. But the LLMs have this kind of database structure, which I think is worthwhile taking a look at. In this first slide, we talk about the pre-training, the making of LLMs, the sort of models that run behind all the Gen AIs, and that these use vector databases. If you've never studied tensor calculus, I don't blame you. I never had either until I made a best friend who was a mechanical engineer in one of my earlier teaching positions. And he, frustrated that I didn't understand any tensor calculus, made me learn some. And it turned out to be very handy because the vector databases that these LLMs use are all about that. Vector databases aren't like relational databases or SQL databases, if you've heard anything about those in the past. These systems take all the words that they read in documents they read and assign a number to the words. And then they group the numbers in their database in proximity to other numbers, in proximity to other words, to show which words tend to align, which ones tend to come near other words, and which ones tend to be aligned in that way. And that's in the entire way in which they generate all the content we've been talking about today. As a result, what they produce looks like understanding, but it isn't. They don't have an understanding of meaning. They can, because of the way they're set up, they can replicate tone, style, or structure of arguments because of the way that language develops. If they read enough examples of documents, they're able to produce documents that resemble the others. There's a little bit of randomness in there, but for the most part, what they do. But they don't actually understand what they're talking about. So it's important to understand that because that explains why they fabricate sources or mix styles or break genre expectations occasionally, especially when the LLM is larger. A lot of the talks we've heard so far today have talked about some of the advantages of the large LLMs, and there are some real advantages to those. I spoke in my keynote about some advantages to the really small ones, which I think also hold up. But it's important to understand that the pre-training is what decides in many ways how big the data set's going to be that generates inside these pieces. Now, there's something else that happens with this pre-training, which is that the database you end up with has a certain number of parameters in it, the sources that are being used. And those parameters are measured. So we'll measure them in something like an 8B or a 14B or a 27B or 1.5 trillion. And these are measures of how many parameters are inside the database. And those generally reflect how much memory the system is going to need to be able to run effectively to produce things. And the really big ones require tremendous amounts of memory. We're going to take a look at some implications of that with a couple of the later technologies that affect the LLMs, though, in the next slide. Bremen, if you could advance, please. There's a means of fine-tuning a database once you've got an LLM generated. So, for instance, Meta has its Llama 3.3 database, and they're going to be releasing at some point very soon Llama 4, and there are a lot of expectations for what it's going to be able to do. But once they release a database, they can then fine-tune that database by doing a bunch of work to sort of include various kinds of specific task knowledges. You can do this much less cost than generating and pre-training a database on its own. And so it's possible to take an open database, like a Llama database or a 5.4 or a Gemma 3, and you can fine-tune that database by adding into it a bunch of content that is integrated into the vector database, adding other kinds of writing. So legal writing, for instance, if you had lots of examples from a lot of legal scholarship and legal documents, you may significantly increase a database's ability to write and to understand, to the extent that it does, legal writing through fine-tuning. The advantage of fine-tuning is that it doesn't take more memory, more high-speed memory in order to run. I've been looking at programs like AutoTrain and Platypus to modify some of the existing LLMs. I had a meeting with TechCom scholar Laura Gonzalez and a couple of her colleagues in January. They're interested in working with some mestiza communities in Mexico, some communities who have Aboriginal languages that are very small in population that speak them. And they were interested in training LLMs to be able to speak and to read and to parse information inside these languages. And I ended up recommending to them fine-tuning existing models, because fine-tuning is exactly the way in which you want to do that. If you're able to do that, it's less computationally intensive than creating one entirely yourself, like a new LLM. And yet it doesn't impose huge memory costs on the resulting Gen AI. As a result, fine-tuning has its real virtues. If you haven't tried these programs, you might take a look at them. Next slide, please, Bremen. Another thing that a lot of the bigger LLMs are doing is fine-tuning, reinforcement learning with human feedback. We've had a couple papers about that already today, and it seems to me that they covered this topic really well. The notion of having human raters look at examples of the text being generated by the system and then rating those on a star system allows you to help it reinforce and positively encourage it in its machine learning algorithms to move towards the kinds of communication that humans rate as good communication and move away from those which are considered bad communication is really valuable. These help improve the system. They adjust the vector positions inside the database, and they allow it to produce better quality output. I'm thinking in here about text database LLMs. There are other kinds of LLMs, obviously, but thinking about this in terms of text, this is how that would work. We need to consider, though, that human raters, maybe from particular, linguistic or national backgrounds. A lot of companies hire a lot of human raters from places like South Asia. And so you may get human raters who are rating based on linguistic norms and standards inside that area. And so there are some issues with human raters that add cultural considerations we haven't been talking about much as we think about the algorithmic structure of how these languages work. But one of the things that human raters tend to reward is vague or deferential arguments. Pointed and argumentative prose coming from a Gen AI often does not get very highly rated. And so those systems are trained generally to try to be more neutral, that is to say, more balanced, more considerative of both sides of a position when it's asked to take a position on a topic. And as a result, I think one of the problems with the AI slop that people talk about is that unfaceted, unopinionated, unpositioned writing, which sometimes comes out of these systems as a result of human feedback. Bremen, if you can move on. So I spoke this morning about my excitement about the new technology coming since 2020 called RAG, or retrieval-augmented generation. The ability to load documents into your system that will then augment and supplement it. These are very expensive computationally. They get loaded into the context window inside of a generative AI. So the Gen AI has a bunch of memory it's using to load the LLM, but then it has this special high-speed memory that it uses for keeping the current conversation in memory. So it knows what it is you're talking about with it, and it loads the RAG into that space. That memory is extremely fast. It needs to be for the system to work, but it's very expensive if you have a big server that's hosting lots and lots of users. It's extraordinarily expensive to host lots of RAG documents inside of a system like that. You can build a system that has more high-speed memory, or you can live with a system that has slower memory. And so RAG systems become quite viable in many ways for this. But as much as I really like RAG systems, I find them most effective when I use a very small parameter LLM model, so that I'm not using as much memory for the LLM. And then I'm able to allocate more memory for the context window so that it then reads the documents that are specifically about this local terrain that it's talking about. And we end up with better conversations and talks about that. I'm happy to talk about that if you have questions or questions about that after the paper. Should we move on, Bremen? We have a super new, exciting standard coming. Everybody's talking about it on the web these days. It's called MCP. And MCP is an emerging standard. It's an open API that allows Gen AIs to connect to live data sources, live databases on the internet. You'll know if you've worked with Gen AIs at all, when you ask it questions, it'll usually not be able to answer for answers that are more than a couple of years old, 1.5 years to 2 years old. That's because that's how big the big LLM generation comes out. And it isn't very easy to integrate newer knowledges into those things. MCP is offering a promise to do that. So we'll be able to develop standard databases. These are usually going to be SQL databases or relational databases. And they'll build a system by which Gen AIs will be able to directly address those relational databases and incorporate the knowledge inside these databases into its context memory. So it'll be able to talk about yesterday's baseball game or today's political intrigues, as well as being able to talk about the things that they can currently talk about. seems to me that these are going to offer some promise for more relevant contemporary uses if we want to see Gen AIs discussing cultural nonfiction. Next slide, please.
Running a little short on him.
Okay. I'll just say then as an overview, it seems to me very important that those of us who are scholars in the field of tech comm think about these sorts of things. We need to understand how those databases work and how they operate. And so we need to participate in the development of best practices. This was the thing I wanted to say in my keynote this morning. It's the biggest conclusion, that the best practices for how we build these systems and how we assess them and how we decide which are going to be the ones that are going to be important in our cultural production have to reflect a whole series of scholars in this field discussing with each other and coming to terms with and coming to standard agreement about what makes these systems responsive. Thank you.
Yeah, I predicted this, that these two would talk a lot. So I'll be brief. I want to leave some time for discussion. I know we have plenty of time left, but anyway. So I'm trying to boil all this down to, what this means for technical communicators, meaning, people who are going to practice this stuff in the field. So I'm looking at kind of content creation specifically and new skills. So go ahead and go to the next slide. So from my perspective, largely as a person with expertise in content strategy and UX, and who tries to keep a pretty active line to the practitioner community, there's three main areas where this is really changing. So for example, the role of a technical writer, okay, or a content strategist. One is reshaping document production. So the way I had somebody come into one of my classes this semester on a content strategy class. She is a technical writer and content strategist, and she talked about how she's dealing with huge amounts of documentation and how that has changed using Gen AI to manage all of that, which was really interesting. And another part of this is trying to automate routine tasks. So, in the practitioner world, they're spending a lot of time still in 2025 trying to structure content in such a way that it's retrievable. What we're doing with our project with RAG is very small scale compared to, I was at a conference, the last ever STC summit actually, and I asked somebody from the audience, how many different docs do you deal with? And she said 30,000 unique documents, right? So doing RAG for that is a lot different in not technologically, but in scale than what we're doing with our stuff. And so there's going to be some adaptation. And I saw this again during the last ever STC summit. If you're not aware why I'm saying that, STC is gone out of business, so it doesn't exist anymore if you missed that memo. But there were a lot of technical writers at that conference that were asking, we had a lot of AI gurus there, and they were saying things like, well, I have this model in my workplace. What do I do with it? How can I use it? So there were a lot of people that really didn't know much about it that were working in, the practitioner space. Next slide. So I think that what we can safely say is that we're going to see a shift. There's still a lot of people, I think, over there in the practitioner side that are still writing content manually. Let me just put that out there a ton. And hearing these stories like, we just debuted the model, no one knows how to use it, so we're still just using our regular workflow. But eventually, they're going to get pushed whether they want to or not to say, hey, this is a lot more efficient. Let's instead of writing this all manually, let's have the LLM produce a lot of it. Then you're moving towards governance, right? And critical engagement. So you're trying to evaluate outputs. Somebody mentioned in a previous presentation, human in the loop, right? And that's really what it is. You, as the human, are still the creative agent who is making sure that the things that we've talked about that LLMs are bad at don't end up going to the consumer, basically, right? If somebody's going through the help documentation and they encounter a hallucination, that can't happen, right? Just like you can't have a human-based error in there, right? So it's going to move from all the production fall on the human to all the evaluation fall on the human, which right now it's both, right? Next slide. And so there's going to be benefits and challenges. One thing is there is going to be a lot of speed and efficiency and scalability advantages, with the caveats that with that come potential accuracy issues. We've talked about these biases that happen. Those are going to get baked in as AI is used more and more in the content space. And you can lose the human nuance, absolutely. And that's a serious challenge. Next slide. So what do these new skills look like? Some of us have talked about these. Some of us are going to talk about these. One is, for lack of a better term, AI integration, right? I hear a lot of these technical writers say, I'm trying to understand how to use Copilot in my existing workflow. And that's going to become an expertise, right? There's already people out there that are consultants that are going in and teaching writers and other professionals how to do that. Like, okay, here's your workflow. It's these 15 steps. Where does the AI go? What can the AI do? So people that get skilled in that will have an advantage. Prompt engineering, of course, I feel like is the main one that we've talked about, right? But that's really huge too. In the context of RAG, imagine if you had a context of 30,000 separate documents. How you prompt that data is going to mean the difference between I get exactly what I want and it's just, nothing, right? It's not effective. Ethical oversight. Again, there's got to be some term for this, whatever we call it, but there's got to be an argument from our field that, hey, we are the people, not the developers, right? The technical communicators can best assess whether this content is biased, right? That still needs to be our role, and we need to argue for that, or we could get pushed out by it, right? And then finally, something like data literacy. And that's what, honestly, from hanging out with like people like Bremen and Jeff, I've improved my data literacy, right? Because there are all these layers to AI. One thing I will say is that like these are still like debatable, okay? And by which I mean, if you read different books, like they'll be talking about during this research project, like, oh, I hate this book, or I really love this book, and I'll look up, and these experts are arguing over what is the data foundation of AI. So a lot of people, from my standpoint at least, don't fully agree what those are. All these questions we're asking, I think, are still up in the air. But people becoming critical consumers of this data, knowing the difference between, I put this document in and the big LLM, coming up with something on its own, that's going to be important, even though we don't necessarily understand the full implications of that yet. Next slide.
That's the opportunity, but I'm going to say we're short on time, so I can be that guy. Oh.
Okay. Go to the end, the very end. Keep going. Right there. Okay. So profession is evolving. Okay. I do not think it's disappearing. I have not, I'm pretty tight with a lot of practitioners. I don't hear they're getting all these layoffs and stuff like that. Other fields, marketing, there are other fields that are getting decimated by AI, but ours seems to not be that yet. We need AI critical literacy. We need to understand the capabilities, limitations. We need to argue for human oversight of these models as they're deployed. And we need to prepare now, and not only us, but our students.